Hello everyone. In this video we are going to learn about the classical substitution ciphers. So after studying the cryptography concept, the next thing which we are going to learn is about how we are going to undergo or how we are going to do that cryptography. The first method that was used in ancient times to perform this cryptography is the substitution method. Okay, so from the word itself you can understand what is meant by substitution. Substitution means you are going to substitute a particular plain text either with another letter or with a number or a symbol. Okay, so for example, let's take a letter A. So if you're taking the letter A, this letter A could be replaced by another letter, or it could be replaced by a number, or it could be replaced by any symbol. So this is the classic substitution cipher. For every plain text letter, you're going to replace it either by a letter or either by a number or by a symbol. So this is the concept that has been used. So the plain text will be viewed as a sequence of bits, and in substitution each of this bit will be replaced by a ciphertext bit. See, for example, in this case there are letters arranged in the alphabetical sequence and each letter is replaced by another letter, or it is substituted by another letter. So this is a classical example of substitution with the alphabets itself. It is not necessary you have to substitute with alphabets. You can use numbers or you can substitute with symbols. Okay, so inside the substitution ciphers, the ever known and the most popular earliest substitution cipher is Caesar cipher, which is named after the famous ruler Julius Caesar, because he was the person who introduced this cipher. Basically, he used this cipher to send secret messages for his military affairs, or to send secret messages to his military people. So the basic concept behind the Caesar cipher is that every plain text letter is replaced by a third letter in the alphabetical sequence. So let's name the alphabetical sequence like A, B, C, D, E, F, G, H, I, J, K, L. Okay, so A will be replaced by an alphabet that comes third letter after A. So which is the third letter that comes after A? It is D. So every A will be replaced by the letter D. Similarly, B will be replaced by a letter that comes third letter after B. Which is the third letter? C. C is 1, D is 2, E, right? So every B will be replaced by E. Similarly, C is replaced by the third letter that comes after C, which is D, E and F. So F will be the third letter. D is replaced by E, F, G. So G is the third letter that comes after D. So this is the concept that is behind the Julius Caesar's well-known cipher known as Caesar cipher. Now this is another example that has been solved. It is a famous example, meet me after the toga party. So this is the plain text which we are going to apply in Caesar cipher. Okay, so this is the plain text. Okay, so you want to convert this plain text into cipher text. So this is the cipher which we have received after applying Caesar cipher. Let's see how this has been applied. So M is replaced by the letter P. How did you get P for the plain text M? Because J, K, L, M, N, O, P, Q, R, S, T, U, V, W. So this is the alphabetical sequence, right? So for letter M, which is the third letter that comes after M, it is P. So that is why M is replaced by with the ciphertext P. Similarly, E is replaced by, you know that after E the third letter that comes here is H, right? So E is replaced by H. So this E is again repeated, so you get the same cipher text H itself. And for the letter T, which is the letter that comes third letter after T, it is U, V, W, right? So T is replaced by the cipher letter W. Again M, it is replaced by P because we have already seen in the first word. E is replaced by H because we have already seen. Then A is replaced by D. See, in this example, A is replaced by D. F is replaced by I. Let's see which letter comes third after F. G, H, I. So F is replaced by I. Again T is replaced by W because we have seen that in the first word. E is replaced by H. R is replaced by U. So which is the third letter that comes after R? It is S, T, U. So R is replaced by U. So likewise, so this is the basic concept behind how you can convert a plain text into ciphertext based upon the Caesar cipher. So replacing each letter by the third letter, that is the concept. So now this is the same alphabets that are being arranged here according to the Caesar cipher. So from A to Z, this is the substitutions that are being used for the respective letters based on the concept that third letter, so every letter in the third is being replaced here. So for A it is D, for B it is E, C it is F, D it is G. Okay, so this is how you can define the entire Caesar cipher's transformation. Now we are going to derive a mathematical relationship. Okay, so for that we are going to give a number for this alphabets starting from 0 to 25. A is an alphabet which is given the number 0, B 1. Likewise, when you reach Z, you will reach the number 25. So in the range of 0 to 25, you're going to give numbers for alphabets A to Z. Okay, so now based on that you will come across a mathematical equation which gives that C, which is a ciphertext, when it is applied encryption to the plain text. E stands for encryption, P is the plain text. So for each plain text bit or letter, how you can get a ciphertext? You're doing a P plus K mod 26. Okay, which means, for example, let's take HAI. Okay, so which is the number corresponding to H? H number is 7, A number is 0, I is 8. So it is 708. Okay, now we are going to apply this mathematical equation. So to get the first ciphertext for H, what you're going to do is you're going to apply the mathematical equation 7 plus, which is the key. What is the key value? 3. For Caesar cipher it is 3, right? So 7 plus 3 mod 26, which is 10, right? So which is the alphabet corresponding to the number 10? It is K. So H will be replaced by the ciphertext K. Now A is nothing but 0 plus 3 mod 26, which is 0, which is 3 itself. So which is the letter corresponding to the number 3? It is D, right? So A is replaced by the ciphertext D. Now it is I, which is 8 plus 3 mod 26. 8 plus 3 is 11. 11 mod 26 is 11 itself. The letter corresponding to the number 11 is L. So I is replaced by L. So we got the ciphertext as KDL for the plain text HAI. Okay, so this is the concept, or this is how mathematically you can define Caesar cipher. Now let's see the decryption. How do you decrypt it? For decrypting it, you have to apply the formula C minus K mod 26. That is the reverse of it. Let's start from this ciphertext KDL and let's see whether you are getting back H. Okay, so which is the number corresponding to the ciphertext K? So K, the number is 10, right? So 10. Now you have to reduce 3 from 10, right? So 10 minus 3 mod 26. 10 minus 3 mod 26 is 7 mod 26. So it is 7, which is the letter corresponding to the number 7. It is H, right? So K is replaced by H. So let me write it here. So KDL. So K will be replaced by H. Now next one is D. So what is the ciphertext number corresponding to D? It is 3, right? So it is 3 minus 3 mod 26, which is 0 mode 26 is 0 itself, which is the alphabet corresponding to the number 0. It is A. So D, the plain text corresponding to D ciphertext is A, and the last one is L, which is the number corresponding to L, which is 11. So 11 minus 3 mode 26. So 11 minus 3 is 8. So 8 mode 26 is 8 itself. So which is the letter corresponding to the number 8, which is I. So the plain text corresponding to letter L is I. So we got back our plain text I from the ciphertext KDL. So this is the mathematical equation to represent Caesar cipher. Okay, to get the cipher you do a P plus K mode 26. To get back the plain text you do a C minus K mode 26. Okay, so hope that's clear. Now all these representations have been again shown here. So the plain text is represented or added with 3 mode 26 to get the cipher. So this is the representation E comma K comma P. So K is this 3. So this is P plus K mode 26, and for decryption it is C minus K mode 26. Okay, so this is all about the substitution cipher or the classic substitution cipher, Caesar cipher. Hope it's clear for you. Thank you.